So, this is now question 3 about trigonometry, and we're back to the kind of area, sector and circle sort of stuff using radians. The diagram shows a sector AOB of a circle, centre O and radius R, and the angle AOB is 72 degrees. Express 72 exactly in radians, simplifying your answer. This is quite nice, actually. I like this idea. Well, what we want to know is what fraction of 180 our angle is, don't we? Because pi radians is 180 degrees. So, 60 degrees, which we know is a third of 180, we write as pi by 3. So it's all about what fraction of 180. So 72 degrees. To write that in radians, that would be 72 over 180 times by pi. That's how we're going to convert it. And 72 over 180, well, most of you have got nice calculators that if you type 72 over 180, it will just use the fractions thing and it will simplify that really nicely. And it will say, 8 over 18. So it would say 4 over 9? That's not right. What was it?
The afternoon radians.
2 over 5. Oh, of course it is. Yeah, that's much better. Just forget that, that's the video. So it'll say 2 pi over 5. Yes, 36 goes in 72 twice and 180 5 times.
I'll do for the next one.
There we go, that's quite a neat one mark. The area of the sector AOB is 45 pi centimetres squared. Well, we've just written down that the area of the sector is a half r squared theta if we're working in radians. So if we put that information together with what we've just been told, we've got that a half times the radius squared, the radius is, well, it is r, isn't it? Times the angle, and we've just converted the angle into radians, so we'll use that as 2 pi over 5. And the question has told us that that is equal to 45 times pi centimetres squared. Notice that by doing this with this exact value including pi, we can divide through by pi. There's a common factor of both sides, so let's get rid of that straight away. We've got, what have we got? R squared, R squared over 5 is 45. So R squared is 225. And if we square root that, we get 15. There we go. Do we need to put plus or minus because we've just square rooted a positive number? We can't have. It's radius, so it's length, but you're right. We can't have a negative length, can we? So we don't need to do this. Okay, that was a nice start. Part 3. Find the area of the segment bounded by the arc and the chord, giving your answer correct with 3 significant figures. What does that even mean? The area of the segment bounded by the arc and the chord. Well, the chord would be that line there, and because I've given some of you out second-hand papers that we've used in the exam, I've noticed that some of them already have that drawn on your exam and maybe even shaded and scribbled in. That's the bit that we're looking for. So it's the difference between the area of the sector and the area of the triangle. And again, right at the start of this bit where we reminded ourselves about trigonometry, we wrote down a formula for the area of the triangle, didn't we? So this is going to be, if we go back, this is the area of the arc, the sector minus the area of the triangle. Now, I tend not to give my students a particular one-off formula for finding this. This is quite a common thing. I think Steve does do this. I think he gives you a formula to learn that gives you the area of a segment, because it's such a common thing. It's a half AB theta minus sine theta, I think. And some people might remember that. Actually, in this case, it probably doesn't help you even to remember that, because we were given the area of the sector. But it's a useful thing if you want to remember that to have it. Here we were told the area of the sector was 45 pi. We were given that, weren't we? And we're looking for the area of the triangle then, and that is a half AB sine C. So in this case, that's a half times AB. Well, they're both the same because we're in an isosceles triangle. So that's the radius squared times the sine of the angle. And now it depends on what your calculator's set in, because we know this angle in degrees and in radians. You just need to make sure that whichever one you use, your calculator's on that setting. So don't use the degrees one if your calculator's in radians mode. Arrange it however you need to. We'll stick with radians, shall we? 2 pi over 5. And somebody's going to have to help me out with this by actually typing this into a calculator, because I haven't got one. I did say answer correct to 3 significant figures. So we just type that in. Henry's been nominated. Oh, let's see. Dave's been nominated. I'm going to get it wrong now. Oh, you've got this crazy German one, isn't it? I just know it did the comma for a decimal point. No, we did it there. I get 34.4. Really? Thank you. That's to 3 significant figures. There we go.